Good morning, students. I hope all of you are fine today. So let's continue with the chapter which we have started in the online class, that is work and energy. Students, in the online class, we have discussed the topic of work. Now we will discuss the topic about energy, students. See, students, in the picture, see a person or a man has raised the axe, okay, which has some energy stored in it. So, if we just allow the axe to fall on the log of wood, then it will cut the wood into pieces. So, what is going to happen? See, students, as we know that all the persons can perform a lot of work, okay, with the help of energy. All right. So, in physics, students, anything which is able to do some kind of work is said to possess energy. So, we can define that energy is the ability to do the work. So, as we have discussed the example earlier, that is, we have raised the axe vertically about the log of wood and some work has to be done while raising the axe. Now see, students, the raised axe is now allowed to fall on wood. So, it has performed some work in cutting the wood. Thus, the work done in raising the axe has been stored up in it, which gives the ability for the doing work. Now, when the axe is resting on the log of wood, then it can no longer do any work. So, to give it the ability to do work again, work has to be done in raising it above the log of wood once again. So, the amount of energy possessed by a body, students, is equal to the amount of work it can do when its energy is released. That means, whatever the amount of energy is stored in a body will be equal to the work that it can perform. Okay? So, we can say that energy is a scalar quantity. That means it will only give magnitude, that means the numerical value, but it will never give any kind of direction, students. Now, what is the unit of energy? The unit of energy will exactly be the same of the unit of work, which is joule, students. Alright? So, if the definition comes that define 1 joule of energy, you will say the energy which is required to do 1 joule of work is called 1 joule energy, students. Okay? So joule is a very smaller unit, students. Now, if you have to calculate the bigger unit of energy, we calculate as kilojoule. And the short form and the symbol of kilojoule is small k for kilo and capital J for joule, that is kJ. Okay, students. So now we will discuss two forms of energy. One is kinetic energy and later on we will discuss about the potential energy, students. Okay. So see, students, the picture very carefully. See, a moving cricket ball, okay, can do some work while we throw the ball into the stumps and it will push the stumps back. Similarly, moving water can do some work in turning a turbine for generating electricity. Similarly, moving wind can do some work in turning the blades of windmill. So, from these examples we can say a moving body which is capable of doing work, it possesses some energy. So the energy of the body due to its motion, it is called as kinetic energy, students. Okay. So now we will discuss about the formula for kinetic energy, students. It is very important. Okay, students. So let us discuss. See, as we have learned that the kinetic energy of a moving body can be measured by the amount of work it can do before coming to rest. So see the picture, okay? There is a body, okay? Such as you can take as ball, or you can take as any other objects, for example car, any other heavier objects. Okay, so just take a body which has some mass and it is moving with a velocity v. Okay, see the picture. Now this ball has entered into a medium m such as air. Okay, which opposes the motion of a body with a constant force in it. So what will happen, students? So the final velocity v of the body will become 0. Why? As because the opposing force, the body will constantly retard, and as a result the velocity will gradually decreases and ultimately it will comes to rest. That is why the final velocity of the body will be 0. Now students, as we have learnt of the formula of work, that is work equals to force into distance. So in shorter form we can write as W equals to F into S. Now see in the picture once again, students, at the position B, the body is at rest because it has lost some energy and it has no kinetic energy in it. That means the kinetic energy of the body has been used up, okay, has been used up totally while doing the work. So the kinetic energy will must be equal to work. So that is why we can represent as kinetic energy equals to W, or we can write as kinetic energy equals to force into displacement. Now, if a body is moving with an initial velocity, say suppose small v, and final velocity, say suppose capital V, now while changing the velocity from initial to final, it will take some time, and for that it will be having an acceleration which is represented by small a, and it will travel a distance small s. So by applying the third equation of motion, that is v square equals to small v square. Small v square is represented as initial velocity plus 2as. Okay, we can also write, or we can also take initial velocity as small u. So instead of writing a small v, you can write a small u. Then the formula will be capital V square equals to u square plus 2as. Okay, so as we have taken all the information, so let us represent this to form the formula of kinetic energy. So initial velocity you can take as small v or as small u. Final velocity capital V will be 0, as because the body has stopped after traveling some energy, after traveling some distance, as because it has lost the kinetic energy. Now acceleration will be minus a. Now why it is minus a? Because as the body has been stopped, so an opposing force acts on the opposite direction. So that's why acceleration will be negative form. The object has traveled a distance which is represented as small s. So now if we put all the values in the equation, that is the third equation of motion, that is v square equals to u square or small v square plus 2as, we can get as v square equals to 2as, or you can say as u square equals to 2as. Now students, from Newton's second law of motion, we have derived as F equals to m into a. So we can also write as small a equals to capital F by m. Now what we will do, students, we will put the acceleration value in the above equation. So if we just place the acceleration value in the above equation, see, the framing of the equation will be small v square equals to 2 into capital F into small s by small m. Then what they are doing, first you need to cross multiply with m and v square, okay, and leave the 2 into F into s. Then just take the 2 into the other side and it will be 1 by 2 into small m into v square equals to F into s. So as we have discussed that the amount of energy which is possessed by the object while moving is the same amount is the work, or it will be equal to work. So F into S equals to half mv square. That means F into S is work done equals to half mv square. So instead of work done, we will write as kinetic energy equals to half mv square, where m is the mass of the body and v is the velocity of the body or speed of the body, students. Okay, so students, this derivation is very important. You need to remember this derivation. Okay students, now students, our next topic is the potential energy. Okay, now just see the picture, students. See, a brick is lying on the ground. Okay, now it has no energy. That means it cannot do any kind of work. But if we just lift this brick in the roof of a house, see in the picture. So while lifting the brick to the roof of the house, some work has been done against the force of gravity. So this work will get stored in the brick in the form of potential energy. So that means the energy which is stored in an object, okay, that energy is called as potential energy. All right, students, okay. So similarly, in the second picture, you can see a car has been raised against the gravity for repairing by a hydraulic jack. So as the car is raised to a height, so that means some energy has been stored. Okay, so this stored energy you can say as potential energy, as because while lifting this car with the help of hydraulic jack against the gravity, so that is why you can also say that this is the gravitational potential energy, students. Okay, students, now we will derive the formula for potential energy. Okay, now see, suppose a body, okay, or an object of mass m is raised to a height h above the surface. That means it has been raised to a height against the force of gravity. Now, so the force acting on the body will be the gravitational pull of the earth, which will be small m into small g, and which will act in the downward direction, as because due to gravitation, students, all the objects will be pulled towards the earth. Now to lift the body above the surface of the earth, we need to do some work against this force of gravity. So that means work done work done will be force into distance. Well, in this case, W equals to force means m into g, and here distance means as the object is raised to a height, so it will be small h. So that means work done will be same as that of potential energy. So the formula of the potential energy will be m into g into h, where m is the mass of the body, small g is the acceleration due to gravity, and h is the height of the body. You can also say as reference point, okay, and it has been lifted against the gravitational force, students. Okay, students, so these are the two derivations of the kinetic energy and potential energy, students. So you need to go through this derivation because these two derivations are very, very important. And remember the formula for kinetic energy, which is half mv square, and potential energy, which is mgh. Okay, students, so in the next class we will do some numericals based on these two formulas of the energy, that is kinetic energy and potential energy. Okay, students, so that's all for today. Thank you.